Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 6, 2025, just yesterday. The striking result is imperceptible jailbreaks that use invisible Unicode variation selectors to hijack tokenization, reaching near universal success against aligned models, and even hitting 100% on prompt injection cases. The paper is titled Imperceptible Jailbreaking Against Large Language Models, and the implications for safety filters are significant. In short, this paper unveils a chain of search method that designs invisible suffixes, yielding harmful responses without any visible changes to the written prompt. That introduction set the threat model. Figure 1 makes it concrete by contrasting visible refusals with invisible jailbreaks that look the same on screen. Variation selectors are invisible Unicode characters that do not change what you see, yet they still get tokenized, which gives the attacker a hidden control channel. The top panel shows a harmful question that triggers a refusal. The bottom panel adds an invisible suffix, so the tokenizer sees extra tokens, and the model shifts to a helpful, unsafe answer. So Figure 2 illustrates why invisible variation selectors matter. They change how the tokenizer reads text, while the screen looks identical. A variation selector is a special Unicode code point that requests a different glyph style, which leaves normal letters unchanged but still adds tokens. The chalkboard compares a plain checkmark with one followed by selector Ucode FE0F, and the token IDs increase because an extra token appears. That hidden change is the lever used to steer unsafe completions. So Figure 2 showed how invisible selectors change tokenization without changing the screen, and Table 2 reports how many tokens each selector becomes across models. Token ID length means how many tokenizer pieces a single invisible selector maps to, which matters because longer blocks give attackers more leverage. For most models, a length of 4 dominates. For Llama 3.1, Instruct 8b, a length of 3 dominates, so invisible suffixes can be more compact. Okay, Table 1 shows concrete token IDs for 3 invisible variation selectors across common tokenizers. The key point is that each selector maps to a fixed multi-token block, which gives attackers predictable handles. For most rows, the blocks have 4 tokens, so a single invisible character quietly injects several pieces. This matters because the exact IDs differ by tokenizer, which means the same invisible suffix can be retuned to steer multiple models. Alright, Table 3 shows that invisible variation selector suffixes top the attack success charts while leaving prompts unchanged. Attack success rate means the share of attempts that coax a harmful answer judged by GPT-4. On Vicuna 13 BV 1.5, the invisible method reaches 100%. On Llama 3.1 Instruct 8b, random selectors stay at 0%, which underscores the need for the optimized chain of search. Well, 2 takeaways stand out. Invisible Unicode variation selectors quietly rewrite tokenization, while the screen looks unchanged, and the chain of search optimization turns that hidden channel into near universal jailbreaks, even full success on prompt injection. The broader implication is clear. Defenses must sanitize invisible code points and add tokenizer-aware checks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.